So, doctor, sir,
Yes.
shall we start now, sir? Now, 9 o'clock.
Yes. Yeah.
Okay.
Right. We will start.
Okay, sir. Good morning, everybody. I'm very happy to uh, introduce our resource person, Dr. A. Halim. He is the head of the Department of Accountancy and Finance, Faculty of Management and Commerce. He has done his PhD in Management and Science University, Malaysia, and he has done his Master of Science in the MIT from the University of California, and he has done his first degree, Bachelor of Commerce, from the Southeastern University of Sri Lanka. He has published many articles. Most of them are Scopus Index articles. He has served as a, chair for many conferences, academic conferences, and he has done a lot of workshop as a resource person, especially in SPSS, AMOS. I also have learned a lot from Dr. Halim, so I also inspired by him, and he has published many articles in national and international journals and research conferences. And so this program is conducted by Research and Innovation Cell of the Faculty of Management and Commerce, Southeastern University of Sri Lanka. So this is the second webinar organized by Research and Innovation Cell. So today webinar is about data analysis using SPSS. So he will give you thorough knowledge about using SPSS for data analysis. I hope you can enjoy the webinar and you can interact with him. He is very expert on this, not only in SPSS, and he is a data scientist. So we can ask any questions. And also I have uploaded the data file in the chat box. So you can click the link, and you can download the data file, the link in the chat box. So Doctor, now over to you, sir.
Thank you, Riyadh, the coordinator for the innovation, research and innovation coordinator of FMC, Faculty of Management and Commerce, Southeastern University of Sri Lanka, for having interactive sessions of this data analysis in SPSS. So the great day and the good day to you all participants, those who are interested in learning, especially the SPSS tools, how we can make use of the tool for analysis purposes. And I guess there are a number of students and from undergraduate side and this postgraduate and other participants also, those who are reading postgraduate and the PhD programs also participated in these sessions. Okay, hopefully the time is allocated to me is 9 to 12 exactly. So I wanted to give you within the 3 hours the full knowledge how you can basically use this SPSS in order to analyze the data and interpret it, and how you can take that interpretation for the decision making process and everything. So within this shorter time, I don't know whether I will be able to cover all the chapters which are very, very important for the analysis purposes. Anyhow, I will be able to manage all that, the content for which I have prepared at this session. Okay, directly I'll come to my sessions. Okay, shall I start at Riyadh? Okay, I'll share my slide. I think you all can see my slide.
Yes, sir, you can see.
Yeah, right. Okay, of course. Actually, today I have been affected by the fever and cough. Anyhow, I'll manage myself, and sometimes my voice may be maybe interrupted to you and for your patience only, right? Okay, we'll do. What is statistics? This is part is very important, because if we know these statistics, then we will be able to have the drive on the directions where we should go, right? So the statistics is very important in life, and wherever you work, and whatever you do a job, and where if you are having the knowledge how you can interpret the data and how you can analyze and interpret the data, definitely the fact and the fact become the knowledge to you, right? For example, this kind of the statistics can be used in many directions. For example, medical officers, they are using it, and psychology, education, sociology, engineering, physics, and business, for everything, right? So there are different type of definitions there, and we can go ahead. And basically, when you take any kind of the data, how it can be used for decision making in a statistics context. For example, the data can be converted into for the purpose of analyzing, and we do analyze, and after that it comes the interpretations come as informations, right? When the level of statistics increase, when you use more tools and more applications for analyzing the data, the level of improvement in decision making definitely will be improved. So that is what this graph shows, that from the basic point of data, the raw material, it's the data is a raw material, from which onward, how we can utilize the data for the decision making, right? So you see here the directions. It shows that the data is converted, move to information. Informations become fact. When the facts comes, right, your knowledge is increased, improved, not increased, improved. When the knowledge improved, that can be used on any occasions, in any situations for decision making. That is what it's called. The level of statistical method, level of statistics where you use, if it is increased, definitely the decision making power will be improved. So that is the purpose. So that's the purpose we do, right? We do the statistics. So that is what nowadays, you see many number of people are reading postgraduate program, even where some people are working in a private organizations, some people are in the academic sectors. So most of the private sectors people are, reading postgraduate program. So why? In order to get the promotions, it's one instance. On the other hand, they wanted to improve their knowledge. If they want to be a smart people at their office, they need some tool, they need some knowledge, they need to have some power. The power will be generated by this statistics knowledge, right? Okay, the important terminologies we are going to see today at this workshop. So we are going to mainly concern on the data and the pilot test, sample size, variable measure, and the scale, right? The data, well, and I'm going to start with this variable. The variable can be classified into two main variables. One is a quantitative variable and qualitative variable. The quantitative in the sense, so for example, any things or any measures can be countable, can be measurable, which is called quantitative, right? For example, so like a height, the height can be measurable. For example, 5.6 inches, 5.9 inches, 6 feet, like that. The weight, 78 kilo, 80 kg, and the age and the examination marks and counts like that. So these are called quantitative variable. On the other hand, the second variable is called qualitative variable. This is a phrase usually describe the scenario, how it is going to describe. So because of that, it is called the qualitative. For example, sex and color. There are different colors are available, and the grade A, B, C, D like that. So blood groups, right? So those things are qualitative variable. And the data, I just skipping some things, right? And the data type of data, right? The type of data can be, again, it's a discrete data. For example, the quantitative data can be classified into two main important sections, but one is a discrete data and the continuous data. When you consider the discrete data, which can be countable, for example, number of females, number of males, right, or number of patients waiting for doctors for a surgery, or number of students sitting for an examinations. When you consider the continuous data, for example, that are measurable, the character can be measurable. One is marks obtained by a student, the particular marks obtained, right? And the body mass index, it can be improved. Time taken, right? Right. When you consider the qualitative data, which can be categorized into the nominal data and the ordinal data, right? Firstly, before getting the analysis part, I just take this all the theoretical part for a few minutes, right? And then I will start the analysis part. Okay. Before going for that, we should know what kind of the data, what kind of methods are available, right? Okay, nominal data. So it can be named if any data, if it can be named, it is called the nominal. For example, gender. When you name for the gender male and the female, it is a nominal. Blood group, right? A B O like that. And ordinal data. For example, if the data is named and ranked, for example, social economic status, low class people, middle class people, high standard, high class people like that, or examination grades like that, A plus, A minus, B plus, B, C plus, C like that. So this kind of stuff, these are called ordinal data, right? So before moving SPSS, right now, for example, most of you are, I think you are reading undergraduate or postgraduate program, where it is a mandatory to do research. When you do a research, it's very important how you are going to collect the data and what to do with the data. With that questions, how you can plan yourself. For example, when I move to this here, pilot test, right? Some people do the qualitative research, and the many other students usually do like quantitative research, right? For example, when we take a quantitative research, so we have to do the pilot test. How we can do the pilot test? Okay, after developing our questionnaire, what we have to do it, there are a lot of procedures are there. We have to do the content analysis and validate the questionnaire, and you have to give that to the experts, and you have to give that to the academics in order to make sure that the theories are validated and the empirical context are included, etc. That you have to concern on when you develop your questionnaire. After that, what you have to do is the first steps, you have to issue that a questionnaire for the selected people, the randomly, whatever the sampling techniques you can use according to your context, according to your objective, right? Okay, of course, now you are ready to issue your pilot test. What you can do for issuing pilot test? How many data minimum needed to do a pilot test or pilot analysis? Actually, if you are taking any response from minimum number of response is that must be 30 numbers minimum. So you can go for 40 or 50 or 60 responses, right? For example, if your sample is a minimum 30, it's quite enough. Because why I'm telling, so I will let you know to the normal distributions. If the minimum number is achieved only, the data will be normally distributed. Unless if you are taking 20 or 15 or 25 like that, there will be the problem in the normal distributions. So that you have to carefully take the data, at least minimum 30 numbers, right? And this is sample size. The sample size can be like a small sample, larger sample, right? When you take a larger sample for your any kind of the study, it's quite enough. When you take a less sample, there will be the number of and multi-quality problems. So when those problems, sorry, when those problems comes to your analysis, you cannot meet your objective, right, through your analysis. So that is what, when you do your research, firstly you have to concern on this your pilot test, and the second the sample size. For example, if your sample size is increased to 500 numbers or 600, 800 or thousands, this must be decided according to your population, right, and according to your study, right? If you already decided this, okay, of course your sample is quite enough, then you can go with your analysis. Okay, I'll come to this the next topic. Okay, what is SPSS? Why we have to use SPSS? Actually, the SPSS is a statistical package for the social science. So very clearly it says that the SPSS software can be used for a social science research, right? When you do, even for the other research also can, but mainly the social science people usually use this SPSS. So it was originated by in 1968 by SPSS Incorporation, and later part IBM. For example, IBM in I think they have taken in 2009, right? They have taken the full control of this SPSS. But this is user friendly because the interface there, once you click that the button and the title, whatever that you want, of course, it is a very user friendly software, and the results will be accurate, and the quality results will be available, right? And also you will be able to use different analytical tools and able to report in a good way, right? So this is the brief introduction about SPSS. Now we'll go to this questionnaire. When you develop your questionnaire, so there will be the different type of measures. The measurements are very important. When you develop your there may be the number of variables are there, independent variable, dependent variable, and the mediating, moderating, control variable. So there are different types of variables are there. And when you develop those kind of a variable, so you have to find the measurement, where you can find all this measurement. The firstly, we have to concern from theories. The second, the empirical studies. Once you collect all these measurement, you have to develop your construct. So that's called this operationalization. From that, from the operationalization onwards, what you have to do, you have to develop your questionnaire, right? The firstly, when you do developing questionnaire, the one is the dichotomous questions, right? This will have the only two possible answers. Only two possible answers: yes, no, or true, false, agree or disagree, like that. So this can be used for a survey. And also there are other way around also, it's there, right? For example, in the second table it says that, what is your gender, male, female, you can click on it. Do you smoke now? Yes, no, like that. Okay. And based on the level of measurement, on the nominal data, if it is a nominal, what we have to do it, we have to give these numbers, the numbers to the responses. For example, 1 for Asia, 2 for Africa, 3 for Europe, and 4 for other nations, like that. And the next level is called ordinal questions. When you develop the ordinal questions, right, you can give the name and the rank. You know, the ordinal questions normally develop based on the name and rank. If it is so, we can give this a rank. For example, the rank, the model transportation in order to preference from the best to worst. The best you prefer, like, 1, and the worst maybe 4. If it is so, we can select which way according to our opinion. We can select the best way, for example, yeah. Or some people will prefer road, maybe the best, and the worst of some people prefer, like, air. Some people, they will select a C, like that. So this is the ordinal questions. And the Likert scale. This is the Likert scale, the mostly used by researchers. Usually these 1 to 5 Likert scales are used by most of the researchers. But for a PhD level, if it is extended to 1 to 7, it is good. It will be very ideal. Because why? The validity becomes accurate when you do more scales, 1 to 7 or 1 to 9, like that. When you have this 1 to 5, between these two gap of 1 to 2 and 2 to 3, 3 to 4 and 4 to 5, there is a gap between 4 and 5. How to decide like that? Your preference may be determined according to the questions. For example, strongly disagree, neutral, agree, and strongly agree. Strongly agree, right? The word is missing here, right? If it is so, between the 4 and 5, agree and strongly agree. Is there any matters, any gap between that? Yes, of course, we can form. If it is so, we can have it 1 to 7 or 1 to 9, like that we can develop. And semantic differential question. Look at the form which is developed here. When you ask a different question to, for example, you got a training, or else we are in this seminar trade, and in order to get your feedback, what you can do, we can develop this kind of the questionnaire and ask the opinion. For example, the seminar or the training is very interesting. Or if you click on this top, it says that very much interesting. When you click here, it is very much boring, or is somewhat boring. Or here, when you click here, somewhat interesting. So this is what the result is going to be taken. Or if you click here on the bottom of this left side, very much useful. Or in the other hand, on other side, we can call it very much useless, like that. So this kind of the results can be generated from this type of semantic differential format, right? And the next one is the Goodman scale. For example, the Goodman scale is a question. Maybe if you take any answer on this, I think you are all agree to the all questions asked here. For example, for a few minutes, just look at the questions is written on this. Are you willing to permit illegal immigrants live in your country? For example, you ticked on the first. That means we permit all immigrants. They can live in Sri Lanka, right? And the second one, are you willing to permit illegal immigrants live in your community? Yes, of course. If you allow, that means you have given the permissions to live in the country. The third question, are you willing to permit illegal immigrants live in your neighborhood? Okay, if you just answer the above two questions already answered, the same, right? You agree on that both questions. Again, would you be willing to have an illegal immigrant live next door? That means from the next door of your house. Of course, you have agreed the above three questions. Would you let your children marry an illegal immigrant? Yes. If it is so, all answers are correct, right? So this is what is called the government scale. And the multiple responses may be taken from this respondents in a differently. If the respondents may choose more than one. For example, please tick against the each statement that you agree with that. Inside the flower, for example, the questions, in opinion, what is or what are the favorite breeding place for Aedes mosquitoes, right? For example, inside the flower vase, water tank, unused tires, fish ponds, and perimeter screens like that. So if you can give them more options, right? You can select one more. And the scale measurement, it is exactly giving this a number values, right? For example, the how many kilometers from your house to your office, from your home to office. So let's say it's a 20 kilometers or 10 kilometers. So it's the scale measurements, right? And those are the measurement how you are going to develop your question. Yeah, and then we'll come to this data analysis part. This is the part that you are all waiting for that. You are all waiting, right? Give me 1 minute. I have some water, please. Okay, thank you. Firstly, if you are interested in doing data analysis, you have to notice there are a number of sections I have mentioned here. One is the data cleaning, or we can call it in other words, the data screening, right? And the next steps to do analysis, descriptive analysis. And after that, there are three main important analysis are there. One is a one sample t-test, independent sample t-test, and one-way ANOVA test. These are the three importance. When you have these more demographic variables, right? Variables. For example, you can carry on. You can do a descriptive analysis, one sample t-test, and independent sample t-test, one-way ANOVAs, etc., etc. Because why? Based on your objective. If the objective is already stated by you, and you can carry on this kind of this analysis. And apart from that, the factor analysis is very important. Factor analysis and correlation the regressions. Okay, we will have this the more knowledge on this all these sections today, right? We'll see what is the data preparations. Data preparation. Under that, it comes like data screening. If you have, for example, you have issued a questionnaire for 1,000 people or 1,000 participants for 1,000 employees. Now you have issued. When you receive the responses from the employees, suppose you have received 800 responses you have collected, right? The questionnaire you have collected from the 800 people. Okay, of course, good. Where you just feed all the data into your Excel sheet or SPSS worksheets like that, etc. Even you can use the both. Microsoft Excel also you can use for entering the data, and after that you can take a copy of that and place in SPSS and paste it, no problem. Or else you can design your worksheet in SPSS and put a coding for all variables, and thereby you can enter the data. So after entering the data, you have noticed something missing. So it is called the missing data. The value is missing. Some values, for example, there are 10 people, there are 10 employees are there. They haven't not responded clearly. They have missed the information, right? So it is called the missing data. And the outlier, normality, multivariability. I'll come back one by one. Firstly, we'll do this missing data. Exactly, the missing data, the threshold level can go for a 10%, right? If it is so, if the missing data, for example, 800 responses, you got it, and out of that you can go for 80. If there are any missing value, okay, you will be able to adjust the data. So the way is here. I will show you in the practice, all right, how you can adjust your data. All right. So this should only be done for continuous or interval data, like age or Likert scale responses, like that. For example, age, you can guess. So the age may be 20 or 21 or 25, 30, like that. Okay, no problem. But scale, Likert scale 1 to 5. So there's a missing values there in the Likert scale. Okay, no problem. You can adjust the data, but basically there's a tools available in SPSS. You can use it. It's not for categorical data like a gender. So we cannot define the response taken from male or the response taken from female, because the categorical data is going to determine the result also. So that is what I told you, right? There are three important one samples t-test, independent t-test, and one way ANOVA test. Those are there, which can be used for deciding the differences, the variance differences of the data, right? For that's the purpose. So we can only use for an interval data, right? And to find out how many missing values in each variable, you can use the descriptive analysis, where you can find the number of items are missing. So frequency report will let you know how many items are missing and how you can correct this. There are two ways are available. One is the mean method, and second one is the median method. Mean method and the median method. You know how to find these, the mean and the median, of course, right? So if you are going to use this mean method, so this is the way that you can use from SPSS analysis. There is the title bar is there, transform and replace missing value button is there, where you can select the variable, and that is going to be changed, and automatically just once you click OK, new variable will be formed in your worksheet. I will let you know right during the class how you can correct this all out. And the second one is the median method. You know how to find the median. The median is the middle number in the argument in the number series. So right, according to that, you can find the middle outlier. The outlier is very important part in the data analysis. If there is an outlier in your data set, so definitely you will have issues in analyzing your data, right? It won't give you the accurate value. There's a problem. There will be the problem in your reliability and the validity also, right? For example, this is called the outlier. In this bottom part, you can notice here 1792 and 4739 and 3258. This is the index is called the record, the data records, right? Where you can find at this point, for example, variable 1, 1792, the value is outlier, right? So like that, from variable 1, variable 2, variable 3, it shows there are number of outliers are available in your data set. What is the solution for the outlier? That is what I told you. If you have more number of sample, you will be able to monitor and adjust your data. How the adjustment mean the removing, deleting, things like that. For example, if there is any outlier, what is the option? So we have to remove that data, because that the data is not consistent with the other variable. Because of that, we have to remove it. You see here, there are a number of reasons. If there are a number of answering patterns available in your data, there's a chance for outlier. One is, if there is any answer like that, 3, 3, 3, 3, 3, 4, all three, it says that, so the person who responded to the question is without reading that. Just blindly he or she made a 333 or 444, 555. If it is so, if there are a number of answer pattern is available in your data, definitely there's a chance for that. And some people answer like that: 1, 2, 3, 4, 5, 1, 1, 1, 1, 1, or 5, 5, 5, 5, 5. So in such a case, automatically it will deviate the consistent of other pattern of answering. So because of that, what you can do, you have to remove that all. Sometimes this is the outlier and the extreme outlier also there. It is a worse for your data, right? And the normality. The normality can be measured by 3 ways. Normality of the data. The data, if the data is distributed like this on the above picture, this is the first picture, right? This means the data is normally distributed, which is called symmetrical. This perfect symmetrical data. Perfect symmetrical data. It is normally distributed. This is what all these researchers want. All researchers want that data must be normally distributed, right? If there is any data, it's, you see here the second picture, there is a positive and there is a negative. This is called skew. Before that, we have to concern on the shape of the data, right? The shape of the data. For finding the shape, we can use the histogram diagram, so which will let us know what direction data are fallen, right? For example, if the data fallen as a normal distribution curve, okay, your data is perfect. And secondly, the skewness. For example, skewness means the responses did not fall into a normal distributions, but it may be heavily weighted toward one side, which is what, that is what it is called. If the tail is the long tail is here is available, this is called positive skew or skew to right. We can say skew to the right, or we can say positive skewness. In this direction, if this curve shows like this is called the negative skewed or skew to left. And the third one is a curtain size. This refers to outlier of a distributions data. Data have outlier, the large curtain size. This is the large curtain size. This is called the large curtain size. All right. This is also, it is a big problem to your data. All right. So these are the three methods are available for a curtain size. And now we'll come to this descriptive statistics. Right. Already the data was uploaded by the coordinator to you, right? If you have the data and if you have the analysis, okay, of course, we'll come to this descriptive. When firstly, if you do the descriptive analysis, the descriptive analysis will let us know what the mean value, which will use the mean value. The mean value is the average and the median, mod, maximum, minimum, range, skewness, term, mean, median, mod, and those things, right? For example, this is the data is given, right? You look at the data. A lecturer recorded the final marks obtained by students in a statistical examination. What he wanted to obtain the descriptive statistics, right? There are data is scattered here for 60 students, right? So the descriptive analysis directly, and again All right. Yes, I couldn't get your response. All right, Kamil. There are a number of. Shall I move? Can you hear me?
Yes,
Yes, sir.
sir.
Yes, sir.
Right. Okay. Of
Okay, sir.
course. I'll move to this the SPSS directly. Give me 1 minute. All right. Yes. Of course. All right. All right. Okay. Can you see my worksheet?
Yes, sir. I can see.
Right. Okay. Of course. So when you click your SPSS, when you load your SPSS, so there will be the two button will be there, right? One is for here data view in the bottom, the data view and the variable view. When I click the data view, automatically all loaded data is available here. You see here the marks, the waiting times, and the grades are here. And when you click this variable view, here we can define the variable, right? Of course. For example, I'm going to define the variable here, right? For example, marks, again the marks, right? Marks 1, right? This is the variable name what we are going to input on this table, all right? Under this variable view. Okay, now you can use your the tab key where these are the variable types. It may be the numerical types, so comma, dot, scientific notations, a date, dollar, customer, string, and the restricted numeric. So these are the types of variable. For a numeric value, we can select the numeric. For any text value, for any text value we are going to select, it is string. You can use the string. If it is a numeric, it's automatically come there. And after that, the width, how many width you want to feed the data. For example, it is automatically by default it's 8. And the decimal, if the any numeric values is with decimal, okay, you can put select the decimal unless you can put 0. And the label, you can put the label to this variable also. Here the variable is a name, and the naming to the variable, right? Or else we can other word call this coding to the variable. So if you are if you want to type the full name of the variable, okay, you can use this label. Here with you can type the name of the variable. Okay, this is the value. I'll come back to you this value, how you can define the values later. And if there's a missing, no, right, align, so you can put the alignment, you can put the right and left alignment. And here there are scale, ordinal, and the nominal is there. For any marks it's there, okay, no problem, it is a scale. Okay, if it is so, and once you finish this, you can see under this under this data view, right? For example, all right, okay, and marks, for example, you put 1, right? Okay, see here 0, and scale, right? Okay, of course this is available now, right? The marks 1 is available. Okay, if if you want to feed the data here, it is there are a number of and as a missing value, right? So like that there, so you can use other techniques how you can fill this missing data. So this is of course filling the data. Okay, if you want to remove this, of course you can select this and clear. Okay, it is removed, right? Okay, I'll come back to the data. All right. Okay, now I have entered this marks up to 60 numbers. So there are 60 students. At this point, you can see the 60 numbers is there, right? So what we can do, how we are going to analyze the data, putting the, after entering all these marks of these students, right? The handout also will be forwarded to you shortly. And how you can do this analysis, go to analysis part and select this descriptive and explore. Look at this explore one by one. If I am fast, let me know, right? Okay, and you can move to this marks to the dependent list, and here, right, what you have to do it, right? They are above the statistics, plots are there. Move to here the statistics section, and you click on this outlier. Continue.
Sir,
Yeah.
the variable will be only displaying in the screen, sir.
All right. Okay. Now it's okay.
Yeah, it's fine.
Fine. Okay. So if it is something's happen, you let me know, right? Okay. What I did here. Now it is all right. Descriptive. Go to explore. Can you see?
Yes, sir.
Yeah.
Okay. All right. Just I'm going to move this marks to this dependent list and go to this statistics part. All right. And the descriptive analysis which we are going to do, and again the outlier, click continue and plot. So stem and leaf already is selected, and the next one is the histograms, and the factor level together also it's already selected, and the next one is a normality plots with test. Okay, and click continue. So these all handout will be forwarded to you. Don't worry, huh? All detailed handout, no problem. An option, no need to select any options here. And after that, click OK. Can you see the output?
Yes, sir.
No, right? Of course, give me 1 minute. This is loading. The output is loading. All right. I'm going to share this output. Okay, now, hi, all right?
Yes,
Yes,
sir.
sir.
Of course, right, okay. So what we can see here from the output, the number of cases, case processing summary. So we have feed at 60 data and the percentage 100. There is no missing value. See here. So how we can find the number of missing from their data? So it will tell us, it will show us how many numbers missing, right? So there is no missing value. And the second table is very important. Second table is very important. Here with I just noted in the slides, the mean value. What is the mean value is 64.75, and standard deviations value, it is here 9.278. So in a statistical context, so how we can write down 64.75 plus or minus 9.2 9.278. So that's a plus or minus. If it is a 64.75 plus 9 mean around it may be the 65, not 65, 75. And when you put to the minus 64.75 minus 9.278, it is like a 55 plus, right? So the variations being it is going to be available from 55 to 75. So all these values are variance, right? And apart from that, the median value. So the median values and the mean value both are very close values. Both are very close. And when you take this minimum, the marks gained by the student, the minimum marks is 45, and the maximum marks the students got from this exam 87. So all the marks fallen within the range 45 to 87. So there is a range 87 minus 45. This is what it is called, the range of 42. And again, skewness is a 0.148 and curtain size is 0 minus 0.042. So according to this skewness research, what will you tell? So already we have covered what is skewness on what is curtain size. Okay, according to this this research, what is your idea? 0.148. Okay, you got my question? You got my question? The data can be normally distributed usually, right? So if there is any value deviate from the mean value, automatically it will bring skewed. The data will be skewed. So most of the data is skewed. That means the skew to right or skew to left, unless the value will be closer to 0. The value will be closer to 0. So hence what we can do, as this value is plus 0.148, it is called positive skew. You understand? You understand? It is positive skew or skew to right, skew to the right. So we can conclude right. Okay. So here the marks is available. For example, there's two options are available. The normality distributions of the data. So there are two methods are here. Kolmogorov-Smirnov, this is the one test, or Shapiro-Wilkie test. Shapiro-Wilkie test. Okay, give me 1 minute. Excuse me. Yeah, frozen. Frozen very well. Okay. Okay, thank you. Sorry. Okay. There is a two tests are available for a normality measurement, the test of normality. So Shapiro-Wilkie test and Kolmogorov. So these tests are used if the sample size is less than 50. If the sample size is less than 50, we can go for Shapiro-Wilkie test. We have to select. We have to concern on this table only. Shapiro-Wilkie. If the sample size more than 50 numbers, for example, we have entered the data 60 numbers, right? 60 numbers. So Kolmogorov's Smirnov test can be used. So if the test is going to be used, what is the results? What is the interpretations of this test of the normality? We have to take the significant value. The significant value here shows that, right? 0.2000. This means it is greater than 0.05. If the value is greater than 0.05, it says that the normality is met. the data normality is met, because we can come to the conclusions based on this mean value and the median also. When you compare this mean and median, the both values are very close, very close. And when you take the skewness also, it is not very closer to the zero, but a little closer to the zero. If it is so, based on this three result, what we can conclude, so the data may be normally distributed, According to that, the normality, test of the normality also show that the data is normally distributed. Look at the histogram, the shape. I told you to test the normality, we can use three methods. One is a shape, second is a skewness, and the third one is curtain size, right? Okay, look at these histograms. When you draw a line, to connect the middle point of the each bar, become the normal curve. When you start the curve like this, it will go here and come down here and like this. So this is what is called normality. Normally, the data is normally distributed. There are two tiles in the left and the right. Right? Okay. And the next one is stem and leaf. This is what will let us know about the data. For example, the marks gained by the students, there are 3 marks available which fall in the 4 digits. One is a 45. That is what we have to take. Stem is a 4 and leaf is a 5. So the one students got a 45 marks. Second students got a 48. And the third students also got a 48. So that is what the stem and leaf plot will state the how many numbers are available, how many marks are distributors like that. When you look at here, when you look at the leaf also in this right side, so you can draw a line. You can draw a line based on the leaf. You see here, this is a normally distributed curve can be drawn, right? So our stem width is the 10 different types of data is available, right? And this is the normal QQ plot of marks. You see here on the line, this is the cross line. When you look at here, most of the data are fallen on the line. If any data fallen here, for example, at this my mouse point, or here, or this point, or here, so which will make definitely outlier. That those data will definitely bring you the outlier report, right? But of course, this our data usually fallen on this line. You look at here. This line shows that the most of the data fall. Only here with only 2, 3, 4 data, which is closer to the line, which are closer to the line. But there is no issue on the data. All right, and this is the next one. So this picture is usually will be used to explain the outlier. When you look at this, the two tails, the top and the bottom, right? And this box, this is the box plot shows that. See here the box plot, which shows that this is the median line. This is the median line. If your all data fallen like this or drawn like this, your data is perfect. This is what is wrong. Okay, this is what is the descriptive analysis from this data that we have taken. Okay, I'm going to share give me 1 minute. The answer for that. Okay. Can you see? Can you see?
Yes, sir.
Yeah, right. Okay. Okay, thank you. It's a loading. My machine is getting slow, right? Because of that. So no problem. Okay, all right. This is the question. This is the case that we have covered. Okay. And this shows the output I have taken from this SPSS output to the Word. You can directly copy and paste it. No issue, right? You can directly copy the output and paste in your Word file. So this is the Word file is available with the explanations. All that what I explained by looking at that the output I explained. All these values are here, right? Okay. This is basically based on the surface table. And the second table, the test of normality, I told you, the test of normality. You look at the way it's written as an interpretation. Sorry. You see here the Kolmogorov-Smirnov test is usually used when the sample size is larger. When the sample size is larger, usually more than 50. If it is so, we have to use that. Right, that can be when the sample size is larger. Okay, all right. In the both tests, if the p-value is more than 5, here this is the more than 5. It is a greater than 5. Okay, we can write like this also. It is a greater than 5. Greater than 5. Okay. So what is say that the data is normally distributed. So one results we got from this data distribution. The p-value of the test is a 5, hence the data can be assumed to be distributed normal. The normality assumption is the foundation of the many statistics tests. So because of that, I just wanted to test the normality before moving to the other tests. Right? If we are satisfied with the normal distributions of the data, definitely all the problem will be solved later. Okay. A number of tests require the raw data to be distributed normal. Okay, we will come back. Okay, after that, the histograms looks quite symmetrical. So according to, as I told you, this is the normality curve is there on the histogram. It shows that is the symmetrical and visible. There are no outlier. If any lines, it's only the upward. Okay, we can have an assumption there will be an outlier, right? And the stem and leaf, I told you how to get these values. Okay, this is the written interpretations there. And the next one is box plot. The box plot says that it will show you this two outlines will be there. It is a asterisk mark and the round shapes, right? It is asterisk marks. Usually this is a extreme outlier, and others usually says that outlier, right? And the next, the case 2. Okay, in such a way, so we can use the case 2 also. See here the question: a nurse at an outpatient clinic recorded the time a patient has to wait before being attended by a doctor. So what happened? A nurse is making record how many minutes a patient is waiting to meet a doctor. All right. So based on that data, she wanted to obtain descriptive statistics, and so this is the record is given for a 45 patient, and how many minutes the patient waited to meet the doctor. For example, 16 minutes for patient 1, patient 2 36 minutes, patient 3 15 minutes. Based on this result, this is the 45 numbers. All right, this is the 45 numbers. So do I want to run this data? Do I want to run this data? Okay, no problem. Right, this is the waiting time in the second column. In the second column, the data is entered 1636 up to, see 45 data is available here. 45 data. The same way, can you see my screen?
Yes, sir, we can see.
Can you see?
Yes.
Yes.
Okay, thank you. Okay, so what we have to do the same way that you have to use for analyzing this data, and go to analyze and descriptive statistics, and go to explore. So it is the waiting time. You can use the waiting time. Okay, and select this statistics. Okay, descriptive and outlier. Continue. Plot. You can select the histograms and the normality. Already the factor level together, it is there, and click continue, and after that click OK. So give me 1 minute, the data is loading, output is loading. Give me a few seconds. All right, can you see the output?
Yes, sir.
Right, okay, this is the output generated by the SPSS. Okay, for example, the mean value is 22 and the median value is 16. So there is a big deviation between the mean and the median. Look at here, it is 22 minutes average time for a patient, right? Out of a 45. So the doctor took the 22 minutes average, right? And when you look at the median value means, so when you put the data in ascending or descending order, the median number is 16, and the standard deviation, it is 11.432 minutes. So the doctor may take time in 20 minus 11. It's 9 minutes. It may be the 9 minutes, all right, or 12 minutes. Okay. So look at here. The minimum numbers is 12, and the maximum number is 16, and range is 48. And when you look at the skewed value, what do you understand from this 2 points, skewness and the cutter size? Skewness and cutter size. So what do you understand from this to the normality test? It says that 1.577, and the cutter size shows that 1.966. It is greater than 1. If it is so, there will be the problem in the data. We can have the assumptions, because if it is a greater than 1, there will be the problem definitely for both skewness and the cutter size. You understand? So when you look at the data, you have to mainly focus on this skewed and the cutter size, because that will only show this normality. Right? For example, here 1.577 mean whether this is a negative skewed or positive skewed, or skewed to the right or skewed to the left.
Skewed to the right.
Skewed to the right. Because why? It is a positive value. We can call this positive skewed or skewed to right. And like that, the cutter size also, it's 1.96. It's a peak. The curve is on the peak, right? Okay, we'll look at the other table, and the test of the normality. You look at the test of the normality. What method we have to select here?
Shapiro.
Yeah, very good. Shapiro-Wilkie test will be selected as the sample number is below 50. As the sample number is below 50, we must select Shapiro-Wilkie test, because you look at the significant value. This is less than 0.05. Less than 0.05. If it is so, The results is the data is not normally distributed. The interpretation of this test of normality, the normality is not met. This is what the result. And you give your point on the argument. The way of shaping the histogram is thrown. Look at this histogram. Look at the histograms table diagram. Look at here. When you draw a line from this middle point on each bar and connecting all the bar, right? Look at here. This can be started from this middle and put here, and again come down, 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 again up, down, and fully down, and then again up. So this is called skew to the right. All right, you understand both skewness and histograms table? You understand?
Yes, sir.
Yes,
Okay,
sir.
very good. This is the way that we can prove whether the data is normally distributed or not. That is what I took, the normal data and unnormal data, right? The problematic data also. One is the normal data and the second one is problematic data. Okay, we'll come to the next. Stephen Leaf, you will be able to interpret very quickly, right? Okay, you look at here the leaf side on this, and when you come to this third row, fourth row, fifth, sixth, seven, like that, it is a less number. So the curve is little peak on the first and the second row number, and the later part is down. All right. Okay, from this also you can give some more idea. Okay, look at this normal QQ plot of waiting time. Look at the line is drawn through this diagram. When you look at the previous output and this output, right, some of the data is away from the line. Am I right? Some of the data are away from the line. All right.
Okay, okay.
Yes, this is the one. This is the one data. Okay, even if you double click on this, you can find the case number, the data number. For example, look at here. It will take time. Okay, all right. It takes time. Okay, so you can find the data number also, and this also deviate from the line. There are number of cases, 1, 2, 3, 4, 5. And again, so look at it is a chart editing. Can you see that? Okay, try yourself from your data. I just close as the time is short. I have to cover everything. Okay, all right. All right. And some more data are available here. Look at here, this state data and this. All there are the deviated. These two also deviated. There are a number of data deviated. Okay, and right. You look at here. You look at here. What is the mean value? What is the mean value? It was 22, and the median value is 16. And when you look at this outline box plot, here there are cases are there for outlier 37, 8, and 11. These three data are the main outlier of your data. Main outlier of the data. Because the doctor took for this patient 37 minutes. Unwantedly, some doctors usually talk much. Right? If you go to this doctor, they look after the patient very carefully and talk their personal matter and the family matter and the country matters, etc., etc. If it is so, what will happen? It may be taken 37 minutes. And for some patients, the doctor didn't take much time. Okay, when the patient enter to meet the doctor, okay, and look at the patient very quickly and send back. Right? Send back. So these maybe happen like that. These are the reason. These are the reasons maybe happen. Okay, when you look at the 37, data 37, data 8, and data 11, I will show you. Data 37, data 8, and the data 11. It is not a 37 minutes. It is a 37 data. Data 37. It's in the row. And this is 8 data. This is 11 data, not the minutes, right? Okay, sorry for that. And when you look at this box, the median line is a fallen because that the median value is a 16. It is not in the middle. It is not in the middle, right? Okay, I will show you the data. What is the 37? You look at here, the data, the time took by the doctor 60 minutes. And for other people, 22 minutes, 26 minutes, 20 minutes. Look at here, 60 minutes taken by the doctor. All right, you understand why it is coming as outlier. And the number 11 and 8, look at here, the 8:48 minutes took by the doctor and the 11:45 minutes took by the doctor. So because of these three data, the outlier is coming. All right. All right, you are clear? Okay, now we'll move to this next. Move to the next. I'll be very fast in order to cover some more sections are here available, so that we have to cover more, right? All right. The next section is under this descriptive analysis, how we are going to analyze the categorical data. For example, the grade is given, the number of A, number of B, number of C to the any test for any examinations conducted by lecturer, conducted by the teacher. All right. So the data is available here. How we can analyze this categorical data? Firstly, you have to enter this data and go with descriptive and frequencies. Herewith, you have to select these frequencies and you have to move these frequencies to this variable and click statistics. No need to put anything here. Select even, mean, median. Okay, no problem. Continue and go to the chart. It is a bar chart. Okay, and continue and click OK. Okay, can you see the output?
No.
No, right? Okay, give me 1 minute. Now, all right. Okay. All right.
Okay, sir.
Right. Okay. Now it is the frequencies there. This is the A, B, C, D, E. These are the grade is given for the marks gained by the students. These are the frequency number of A, 4, and B. B, 12 students got B, and C, 28 students got C, and D, 13 students, E, 3 students. So like that is the total and the percentage, and the cumulative percentage also is given here. And this is the graph also show that the same way how the frequencies are plotted on this pie chart. Okay, this is what the categorical data. All right. Okay, now we'll move to. I'm going to move to my slides. Okay, this is what we have seen. Okay, one sample and excuse me. Sorry. Okay, up to this point, we have gone through. All right, we have seen categorical data. That's over. And the next slide, so one sample t-test. I'll cover this after the factor loading. One sample t-test, right? Independent sample t-test, so one way ANOVA, everything is here. And we'll come to this factor loading and factor analysis. Okay, this is a very important area. Very, very important area for factor analysis, right? How to do this factor analysis. Okay, shall I have a few minutes break for 5 to 10 minutes?
Okay, sir. Yeah.
Okay. Riyadh, are you here?
Yes, sir. I'm here.
Right. Shall I have a 10 minutes break?
Sure, sir. We'll start at 10:30.
Yeah, right. Okay. Thank you. Thank you very much.
Okay, sir.
Good day again. The next one is very, very important, because why I'm telling the factor analysis is a major part of doing the new research or new area. Right. Before coming to that, I'll just bring another slides. I'll show you the. Right. Okay. Look at here. This is a multiple linear regression analysis. So where here the model is developed, right? The model is developed based on this model. I'll come back to this factor after looking at this the model, research model. We can call this a conceptual model also, right? From, for example, this model can be developed basically from theory. One is from theory. But theory says, okay, the same theory can be tested in a different context. And also, this conceptual model can be developed basically with the support of theory and the empirical studies. So some more variable. For example, when I take the this as a one variable, which was taken by the many researchers, many scholars in connections with the theory they have taken. Okay, so for that for that context, we are also going to use the different model to the different context. So like that we can develop. So basically, if you want to develop a conceptual model, we have to use the two things. One is empirical and the theory, and the second one is the empirical. From these two only we can develop, right? Unless we have to go for this qualitative analysis, and we have to form the measures, we have to form the variable from the different, that is going to be the in-depth analysis, right? Okay, so this is the model. Why we must carry out the factor analysis, if these variables or if the item in the measures are new or not studied, only few studies carried out. In such a situation, we have to do a factor analysis. Because why? That factor analysis cover under the EFA, exploratory factor analysis. In addition to that, where we can do this factor, even for the confirmatory factor analysis also we can do. For the confirmatory factor analysis means already the model was validated by the many number of researchers, or that model is a theory. So when we are conforming to the context, so we can use that as the confirmatory factor analysis. So if that the model is from the, basically it's derived from this EFA, exploratory factor analysis that we are doing. And again, we have to do this factor analysis. Okay, I'll come to this factor analysis, how to do, right? This is a variable here. For example, F or technology is the factor is the one variable. We wanted to find a number of measures. For example, measures 1, x1, x2, x3, x4, x5, x10, up to 10 items that we have found. We have found from this literature. We have found all these 10 items from this literature, and we are going to accommodate with the variable. All right. In such a case, for a three all variable, if you are taking for all variable like this, for example, there are 4 variables are here, These are already I explained to you. These are the 3 independent variable, and this in the right side, the MAP is the dependent variable. For all 3 that if you are going to develop the measures, for example, STR may have 5 measures. TEC also may have the 5 measures, and COM also may have this 5 measures, and MAP also may have 5 measures. So basically we have derived it from this literature, right? Okay, this is the assumption. For example, if you are going to do this factor analysis, what we have to do it, how we can do? One is, for example, loading the factor. We have to collect the data and generate the correlations matrix. I'll show you how to do this correlations matrix, and the extraction of the initial factor solutions that we have to find, rotation and the interpretation, and the construct of the scale. So from the basic, the factor loading, what we can do, we can develop a construct. All right. For testing that the factor analysis, what we have to make sure KMO value. This is the validity test. This test, the KMO will let us know the sample adequacy. Right? This is the measure of the sample adequacy measures. So the proportion of the variables, variance in the variable that might be caused by the underlying factors, right? And again, what we have to do, this KMO value must be greater than 0.5. Must be greater than 0.5. If that 5 is, it is considered poor. If it is equivalent to 5, we can conclude it's a poor KMO value. But if it is a 0.5 to 6, okay, it is a considerable medical. And if it is a 6 to 7, it is a considerable acceptable. We can accept it, right? And if it is more than 7 to 8, considered good, and above 8, it's excellent. And the next test is the Bartlett test of the sufficity, right? This must be between 1 and 0. This is the diagonal value. So diagonal values are 1, and the off diagonal values must be 0. So these are the basic rule of thumbs for doing factor analysis. So as I explained to you, these are the from this variable 1, variable F, there are a number of items are available. Based on that, we developed. For example, if you are asking a questions, if we develop a question under the 1 variable, for example, technology is a main variable for which we will be able to find the measures from the literature. There are 5 or 8 or 10 measures are available. Okay, bring that all measures. We can call it in another word indicator, or we can call it item also. We can name it, right? So if we put that name differently, no issue, right? And so if we bring it, and we have to test the consistency of the item, right? Okay, how we can do that? Okay, so the next one is the variance, total variance extracted. The total variance extracted must be at least 50%. At least 50%. If it is a 5.5, it says that it is a 50%. Okay. So these are the summary. These are the summary of the factor analysis, right? And I'll take you to this factor analysis, and I'll come back to this multiple linear analysis again, right? Okay. Okay. Okay, under the variable view, can you see data sheet?
No, sir.
No, right? Okay. Now, all right.
Yes.
Right. Okay. Thank you. Right. This is the variable view. So where we have developed a variable. This is the data sheet. It's already shared by the coordinator. So for example, we have the name here: STR1, STR2, STR3, STR4, and the second variable TC1, TC2, TC3, TC4, and the next one is a COM1, 2, 3, 4, and MAP 1, 2, 3, 4, according to this model that already I have shown you, right? Okay. So what we can do, firstly, we can do this effect analysis in the two different ways, right? Firstly, I'm going to bring to you to one by one all the variables, right? And how we can do. For example, so this is when you click this data view, the data view. Can you see the data view? Give me 1 minute. Can you see the data view?
Yes, sir. It will be.
Hello? Hello?
Yes, we can see.
Yeah, okay, thank you. So this is the variable view. The variable view, we have defined all variable. So how we can define here, for example, as I told you, I will explain to you how we enter the values here. For example, str is the one variable, and this is the numeric value. So we are giving 1 to 5 as a scale data, and this is with this 8, and the decimal is 0, and the label we can put even for example strategy, right? Strategy 1, strategy 2, like that. And when you click here, this is the way. For example, value, if I enter the value and the label, if I enter this value 1, so strongly disagree the label, so you can click add, automatically it will come. So like that I have developed all these 1 to 5 here, and other things are all right. And when you come to this data view, and how we are going to do this effect analysis, okay, so directly you can we can click analysis, okay, can you see, and click on dimension reduction, right, and click this factor analysis, right. Now what we can do, we have to select these to all this item to the right side, to the variables, all right. And there are a number of tabs are available here under the descriptive. Go ahead with this selecting the descriptive. Under the statistics, what you have to do it, you have to click on this univariate descriptive, and under the correlations matrix, click on this coefficient, and the next one is a click on KMO. After that, click continue. From this extraction, there are a number of methods are available for selecting the method. When you click here, There are principal component, unweighted least square method, centralized least square method, maximum likelihood, principal axis factoring, alpha factoring, image factoring. But the mostly used method is a principal component matrix, and some other research, some other analysis also, we can use a maximum likelihood also in a different for a different analysis. Right after that, we have to click continue. Right, and the rotation. So the rotations method, the data will be rotated in order to bring the value. There are Varimax and this Promax is the mostly commonly used the method. The Varimax can be used for a small number of samples. Right? The Promax can be used for a large number of samples and for the social science research. And for the social science or social science based research. Okay, we can select this Promax. So automatically the rotated solutions will be loaded and click continue. And score, we don't want to save at the moment, right? Okay, this is what we have to select. Okay, click OK now. Once we click, right, so can you see the output? Now, all right, can you see my output?
Yes, it's visible, sir.
Yeah, thank you. Right.
What is the version of this software, sir?
Sorry?
What is the version of this software?
It's a 23, SPSS 23 and 26 also available.
Okay, sir.
If you are in need, our coordinator will share the SPSS also.
Okay, sir. I have older version which don't
right.
have the factor analysis.
All right. Okay. You can use the 23 or 26. It's good. 26, I think, good, right? It's a more advanced. Some more features are available. Huh?
Yeah.
Okay. Now look at the descriptive statistics output. The output shows all these 4 variables are here. It's the mean value is 4.2, 4.57, 4.6, good. But when you look at this correlation matrix, the correlations matrix can be used to test the convergent validity of the construct mean strategy. In other words, we can call it a variable, right? For example, there are 4 items were selected from the literature and issue the questionnaire. We have collected the questionnaire and we brought into the data, right? Okay. After that, what we have to do, we have to check whether all the items, item 1, STR1, STR2, STR3, STR4 are consistent with the context of strategy. So that is what those items must have a intercorrelation, intercorrelations among STR1, STR2, STR3, STR4. How we can determine whether these all 4 items are intercorrelated to the particular variable? The particular variable is called strategy. So look at here, the STR1 is a less number. So basically the rule of thumbs is there. If these items values less than, the item values must be greater than equal to 0.3 and less than 0.85. You understand the rule of thumbs? You understand? The value must be fallen between 0.3 and 0.85, or some other researchers suggested 0.9 also, right? So those values, for example, other values, when you look at here, this is the 3.23, and this is the 3.28 like that. So if it is less than 0.3 or above 0.85, the rule says that we have to remove that item from the context. We have to remove that item from the context. Okay, I'm going to remove that item. Go to analysis again. Go to click dimensions reduction and go to factor. Okay, here with you can look at here. Mostly the strategy 1970 0.031 0.134, these are less than 0.3. Okay, I'm going to remove this first and do the analysis again. Okay, click OK. So what happened right now? What happened right now? All right, it is 2 is here, 3 is there, 4 is here, right? Okay, keep this for a moment. I'll bring to you, right? Keep this for a moment. For a moment, right? And when you look at this KMO value, this is a greater than 0.629. 0.629. Okay, and this the total variance explained. The total variance explained is greater than 0.54, right? So it is this means 50% above, 50% above, 50% above. So that we can take the factor loading 50 above 50. So when you come to this component matrix, if it is a greater than all these 3 items, you look at here, strategy 2, strategy 3, strategy 4, those all items are greater than 0.5. This is a preferable. If all item greater than 7 is excellent values. These are the excellent value, right? Okay, this is the way if we are doing for a confirmatory factor analysis, not the EFA, confirmatory analysis, we can do this factor analysis. Okay, now I'm going to directly coming to the factor EFA analysis, exploratory factor analysis. After loading all item into one data, right? Okay, how I can do again? Pick a dimension, factor loading. I just reset everything, and selecting all the item here to here. Okay, here to here. Now it is a factor loaded variable, and the factor analysis variables are moved to this under the variable section, and click on descriptive, click univariate coefficient and KMO, click continue. Extraction, principal component, already I told you. Rotation from X, click continue. Right, score at the moment I didn't save this, we will save this later. Cancel. Okay, click OK. Click OK. What happened right now? All these values are loaded here. Right, the KMO is greater than 5, and we will look at this table later. Look at item intercorrelations, and communities values are good. And here are the number of total variance explained. There are number of factors loaded. 1, 2, 3, 4, 5 lines. How many variables we have? Only 4 variables, but it has loaded 5. When you look at this table, pattern matrix, some item, when you look at the item STR1, under the component 1, there are 5 components loaded here. Under the component 1, it shows that 0.5754. Under component 2, minus 0.27. 3 minus 0.153, 4 minus 1666, 5 minus 165. And when you look at other variables, second strategy 2, it is located under the component 3. And strategy 3, the value is greater than 5. We have to look at the value greater than 5. Okay, and it's fallen under the component 3. Okay, strategy 4, it has been fallen under strategy 4 under component 3. Or other values are smaller values. Okay, how we can remove that all these smaller values? How we can remove and see the pattern matrix, how these pattern all factors are loaded. Okay, I'll do this same analysis again. I'll do the same analysis in order to show you how we can remove these small values. Okay, go to analysis, dimension reduction, factor loading. Under the extraction, fixed number of factor to extract. Fixed number of factors to extract. So actually we wanted to form a model. We wanted to form a model with the 3 independent variable, 1 dependent variable. So altogether 4, right? So I'll put here 4. When I put 4, right, automatically it will be, the component must be fall into the 4 groups, right? Okay. Okay. And the rotation, okay, rotation, okay. And the score, that also right. And give me 1 minute. Extraction, it's okay, all right. Extraction. Okay, so this can be continued, right? Okay, so if it is so, what is happening, right? This is usually it formed of the 4 component. Look at here, 1, 2, 3, 4. All right, how many components? 4 components form. Again, we can remove this less number. Give me 1 minute. Okay. Again, go to the dimension reductions, factor loading. Option, right? Option. This is where you have to click this suppress small coefficients. You have to click on this. This is the absolute value below. For example, we can put 40 because the value must be above 5.5. Above 0.5 is a preferable. Okay, I'm going to put of the 4 here. Okay, no problem. And click continue. Click OK. Once you click here, what happened to here? You see here the pattern matrix. The pattern matrix form factor loading. For example, under this component 1, 2, 3, 4, it's formed. But here the strategy 1, strategy 2, strategy 3, strategy 4. All 3 items are, these strategy 2, 3, 4 items are located under the component 4. That's good. As this is a deviated, and this come under the component 1. For example, this is the communication related question. This is the communication related question. 2, 3, 4. All these 3. But this is the strategy level questions. So this is not matched with this communications related question. Because of that, what we have to do, we can remove this strategy 1. Okay, I'm going to remove that strategy 1. Strategy 1. Okay, I'm just explaining one by one. Okay, no issue. Okay, after that, you can look at here pattern. All right, now we have to look at here. We have to look at here. This strategy component is good, and the technology component also it is good. The 3 components are formed, but the TEC4 the variable, sorry, not variable, the item 4 is not available. What we have to do it, we have to remove that also. Technology 4. All right, remove that one and click OK. Right. So this is a technology, all right, and the strategy also all right. But this is when you compare this communication. The communication we have a 4 items, but this is a communication 1. This is the cross loading. It is a cross loaded under the component 2 and component 4. If it is so, what we have to do it, we have to remove this one. We have to remove this as it is a cross loaded. So we have to remove this from 1 also. Okay, I'll bring here down. Right. Okay. Click OK. Now look at here. Pattern. Okay. Now what happened? These all three pattern matrix, all 4 are fallen in a different variable. So we can name this. We can name after this. If we are running EFA, exploratory factor analysis. What is exploratory factor analysis? If you are going to do a new research or new item to the context, or very little or few studies only used this variable and item, and such situations, what we have to do is we have to load the factors and see what items are fallen to the particular under the variable name. So what we have to do, we have covered here. Strategy is separated. Okay, technology also is a separate variable, and communication also separated, and MAP also separated. All right, and again, what we can do in order to test the item intercorrelation, as I told you, the 2 way we can do. Firstly, we can do the item intercorrelation, and secondly, we can do this factor loading. Or else what we can do this factor loading first, and again come to test the item intercorrelation. Okay, now we have to take the node, right? str2, str3 and str4 is one variable. So str3 4 not 2 2 3 4 it's become 1. Okay, and the TEC we have to check 1 2 3. Okay, all right, and the com we have to check 2 3 4. All right, and MAP it is 1 2 3 4. These are the 4 items. So we have to check the item intercorrelation first. Okay, go to analysis, go do this dimensional reduction. Right, I am going to reset it again, and what we have to select this 2 3 4 for the strategy, and test this value, univariate, coefficient, and KMO. All right, extraction is going to be the principal component analysis. Extraction is going to be a principal component, and the rotation is from X. All right, and score not saved. Okay, and everything is all right. Now click OK. Now what we have to do, we have to come here, write strategy 2 3 4, right? And there are 3 items are here, 2 3 4, but we have to check this. This is a 2, it's below 3. That's what I told you in the beginning. When we run this correlations matrix, only 1 item we have removed. I kept this a 2, and after checking that the factor loading, we wanted to come to here. Okay, This is what the point, the value is less than 3. This value, for example, I have pointed here, the value is a 281. If it is a less than 3, what we have to do it? We have to remove that one. Even we might have removed at the beginning. Okay, that is what. But I wanted to show you the difference. That is what I wanted to show you the difference. If we removed it already under the factor loading, we will be able to get only. Can you see my output?
Yes, sir.
Yes,
Right,
sir.
okay.
Yeah.
Okay. So what I want to do it again, I have to remove this number 2, right? Okay. Number 2 is removed. So now we are going to take for our final analysis only 2 items from strategy. Only 2 items. That is 3 and 4. You have to note it down. Okay. All right. So look at the output again for the 2 item. Look at here. It is about 0.3. It is about 0.3. And you have to check this KMO value. It is a poor value. It's a poor value. Is a 0.5 is poor. That's what I told you. And the total variance, only one variables are here. It is above 50%. You see here the cumulative value is above 50%. And one component only formed. All these 2 values are above 0.7. So it is a perfect value. And in such a way, the same way we have to do to the second variable and check that TC, right? TC we have taken 1, 2, 3 only. Already 4 removed, right? So look at here. Can you see my output? Can you see?
Yes.
Yes.
Right, okay. So when you compare this correlation matrix between this item intercorrelation between TEC, TEC2 and TEC3, all the values are between 0.3 and 0.85. Are you all agree? Are you all agree? All values are between, not this a diagonal value, 1, 1, 1. Don't take that diagonal value. You compare this TC1 and TC2. This is the value is a 0.592. TC1 to TC3, it is a 0.432. So that is the way we have to compare. So these values are fallen between 0.3 to 0.850. Okay. And the KMA value, it is above 0.5. It is a good. Okay. And when you take this TVE, not a TVC, TVE, total variance explained, it is 60%. All right. And the total component matrix, it shows that above 0.7. Okay. Now we have checked these 2 values. Okay, good. And we'll move to the next variable. We'll move to the next variable. Com 1 to 4. What are the items we have taken? Com 2, 3, 4. Right. Okay. I'm going to move to the here 2, 3, 4 only. Okay, I have already noted. And you don't want to tick it again and again. If you just if you click the reset button only, we have to check recheck all the values we have put over there. Unless you can just move here and click OK. Okay, all right. After clicking this one, okay, click all right. When you click when you compare this correlation matrix between COM2, COM3, COM4, all the items are perfect. All these values are fallen between 0.3 to 0.85. And the KMO value is 0.675. And this is the significant value. This is good. And when you compare to this TVE, total variance explained, this is a 71%. It is above 50%. That's good. And when you compare the component matrix, all these values are above 5 and above 7. Excellent value. Right. Okay. The final value we have to test it, and we have to move this And what we have to do it, MAP1 to MAP4. All right, MAP1 to MAP4. Okay, we have selected these values, so 4 values, right? MAP 1, 2, 3, 4. All right. Okay, we have to test this. What is happening here? What is happening? You just let me know what is happening from this correlation matrix according to the rule of thumbs. Yeah, anyone? Let me know.
Some values are more than 0.85.
Yeah, very good, right? The value is greater than 0.85. What is the rule says?
It should be between 0.3 and 0.85.
We have to remove that one.
Yeah,
Isn't
we
it?
have to remove. Yes.
We have to remove. So MAP2 can be removed. MAP2. Here you look at here, MAP2. Okay. So we have to remove this. All right. Okay. Now we have to check it again. Okay, all other values are. So I have taken example to show you here less than 3 and greater than 0.85. You understand? One value we removed less than 0.3, and other value in a second example I have taken greater than 0.85. So we have removed one. Okay, so under this correlation matrix, what it shows that so MAP1, MAP3, MAP4, all these values are between 0.3 and 0.85. And now we can check this KMO value, right? This is a 0.672. So this is the ideal. Okay, and this is significant. And we'll have to come to the TVE. It is the 64%. And when you compare to this component matrix, okay, this is 770, MAP it is 829, and MAP4 it's 0.803. Okay, these are all good values, excellent value for the purpose of doing further analysis. Okay, this is what we have done. Right. After that, what we have to do it again, we have to go back to our factor loading in order to make sure all the rest of the values are available in order to load the factors, right? Okay, go ahead. Dimension reduction, factor loading. I'll bring all here, and after that I'll be able to remove all the values, all the item. So already we have removed 1 and 2 also removed. That is what in the strategy 3 and 4 it's available. Under the TEC, the 4 already removed, and I'm going to remove, and this also removed. And from the MAP, lastly we have removed MAP2. Okay. So these are the final item of the variable. These are the final item of the entire construct. Okay, now we have to put the name to the construct through this factor loading, right? Okay, to that purpose, we have to select all these things. Okay, good. Extractions, we have to make sure this principal component analysis, and we have to fix this number of factors to extract, because you know we are only forming only 4 variable. Okay, this continue, and under the option, before that option, we have to select this Promax. We have to click on this Promax. Okay, good. Continue and come to this option. Okay, this suppress small coefficient, absolute value before 40 or 50, no problem, right? Even you can put a 50 also, no problem, right? Put a 40, right? We'll see. Continue, right? And click OK. Now we'll come to component matrix. This is what Okay, so here, look at here the component pattern matrix. So item 3, right? This component 4, the name component 4, we have to note it down. Component 4 is the strategy. We have to note it down in your notebook. And because why? After it's saved, we have to put the name. We have to put the name to the variable, right? And the second, it's a 1 for, it is a 2, technology 2, right? 2 for technology, okay? And 1 for communication, and 3 for management accounting practice, MAP, right? Management accounting practice. Okay, now we have to save this. We have to save this. Okay, I am going to save this. Again, you have to go to analysis, go to dimension and factor, and you have to come to scores. You have to click on score. We have to click on score, and there is a button called save as variable. So what is going to happen when you do a factor analysis? This will save as a variable. This will save as a variable. I'll show you, right? Click on this and click continue and click OK. After that, you have to open your data. Open your data. Can you see my data open? Can you see my data?
Yeah, sir, we can see.
Yes, sir.
I'll share it again. All right.
Yes.
Right. So when I move my mouse pointer to the last column, there are 4 different values are formed under this, under the data view. You see here, factor 1 days 1, factor 2 days 2, factor 3 days 1, factor 4 days 1. So because of that, we couldn't, we cannot define the name if the factor 1, factor 2, factor 3, factor 3, 4 like that. So that is what I asked you to make the note, right? We already noted 4 for strategy, 2 for technology, 1 for communication, 3 for MAP, right? Here, this is the 1, this is 2, this 3, and this 4. All right, how we can name this for our variable? Okay, come to the variable view, click on variable view. Okay, these are the 4 names are here. What is one? One is a communications. Okay, I'm going to change the name. All right, for example, I'll put double M, right? Double M, and I'm going to remove this. All right, and this is going to be the scale, and this is a 2 is for technology. This is a 2 is a technology. Okay, I put this a TECH, right? And remove this. 3 is MAP, right? MAPP. I'll put it MAPP, right? As this is a variable, I put like that. All right. Okay, and this is 4. This is the 4 is strategy. Okay. STRR. I put STRR. So these are the 4 variables we have found. One is, you know, dependent variable. Other three are independent variable. Are you all right up to now? Okay.
Yes. Okay, sir.
Okay. Now we'll go to, after this, very important analysis are the correlation and the regression analysis. Now we have defined our variable through the EFA analysis, exploratory factor analysis. What we are going to confirm, we have to do our correlation, we have to do our regression, right? And then after only we will be able to prove our objective. Already we have selected the objective, we have written the objective. For example, technology has an influence on management accounting practice. This is your objective, right? Or second objective, for example, and strategy has an influence on management accounting practice, and communication has influence on management accounting practice. These are the objectives, right? So how you can prove this? For that's the purpose. So we have to run correlations. Why we have to run the correlations? Correlations only will let us know the association between the variable. Association between the variable. And when we run the second step, regression analysis. What is regression analysis? Regression analysis will let us know the relationship between the variable. What do you understand by the association and the relationship? Are these two terms are same? Two terms are same?
Yes, sir.
Yeah. Yeah, let me know. Yes. For example, if you are being in a society as a member, you are associated with the organization, right? You are a member. But when you be in when you be in a family, you have a relationship with the other members, right? Father, mother, sister, brother, wife, etc. Right? And the relationship can be used to find the explanatory power, right? What is the impact of that variable? For that the purpose, these regressions can be used, but this correlation can be used for testing the association, right? Okay, we will do how we can carry out the correlations and the regressions, right? Okay. After naming this variable, okay, directly we can go with the variable view or data view, no problem, right? Because our title bar is over there, and directly we can click on the variable view or data view. Okay, I'm going to click on this analysis. You can find this correlation here, correlation, right? And then you have to click this bivariate. I'll tell you univariate, bivariate, and multivariate. What do you understand bivariate?
Association with two variables.
Univariate?
No idea. No, sir.
One to one. Univariate is a 1-to-1. One independent variable and dependent variable. So that is a univariate. If there are two, if there are two variable as an independent variable, which is called bivariate. If there is a more than two variable, for example 3, 4, 5, 6, whatever, it is called multivariate, right? As from our example, we have a 3 independent variable. Am I right? All right. How many variables we have? Independent variable? 3. So, right, I'm going to move to here, and I'm going to bring this last to MAP. All right. communication, technology, strategy, and this is the dependent variable. Under the correlation coefficients, we are going to test this PSN correlations. And the test of significance, we have to test this two-tail test. Two-tail test. Under the normal distribution curve, we can test the left and the right. Right? Okay. So the significant value must be greater than less than 0.05. So because of that, the two-tail test, we are going to test it. Okay, under the options, nothing to select here, and the style also no need, and directly you can click OK. Now can you see my output? Can you see my output?
No. No.
Okay, I'll share this. Now, all right. All right.
Yes, sir.
Right. Okay. From this correlation, this is the correlation is going to check between the variable. There are three variables are here: communication, technology, and strategy. With MAPP, this is the dependent variable. So we can check this association between. For example, here the communications to MAP, the last row. So PSN correlation value, R value is 0.345. R value is 0.345. And the significant value, for example, right, the P value, this is the P value, two-tail P value, this is less than 0.05. Or we can call it, in other words, 1 also, right? As it is, all these are 3, we can call it less than 0.01 also, right? So this is the significant. So there is a association. The results we can interpret. There is an association between COM and MAPP. All right. Okay. Right. Second, we have to test technology with this MAPP. Technology, this PSN correlation R value is 0.124. 0.124. But the significant value is 0.123, which is greater than 0.05. This is greater than 0.05. So what we can conclude, so there is no association. There is no association between technological factors and the MAPP. And when you come to this third variable, right, STRR with MAPP. So the MAPP is, the R value is 0.166. Those are weaker relationship, right? Weaker association, not the very excellent association. If it is like 8 to 7 like that, it is okay, right? All right. Okay, so the P value is, two-tail P value is 0.039. 0.039. So this shows that there is an association between strategy and MAPP. Okay. In addition to that, this is the conclusion, as I told you. All three conclusions we made for proving our hypothesis, right, based on the correlations values. Right. In addition to that, we have to check the intercorrelations values. Intercorrelation between COM and, for example, here the COM and technology 195, COM and strategies, like that. If there are any values, if there is any values greater than 0.9, so there will be the multi-collinearity issues, multi-collinearity problem. Right? I'll come back to you later, little later. Right? Okay. So this is what it is a correlation. Next analysis is called regression analysis. Next analysis is called regression analysis. Okay, we'll do this regression analysis. So the same way we have to go to analyze, dimension reduction, not to dimension, sorry, and regressions. Click this regression and go to linear. Right, we have to bring down. So this is the dependent variable. So we have to move this MAPP to here. And all these three are independent variable. We have to select these three and move to this independent. All right. All right. And we have to click this statistic. Right. Click on coordinatory diagnostics. Click on coordinatory diagnostic. Click on descriptive. Click on Durbin-Watson. Continue. And the plot, we have to ZPRED to x-axis, ZRESID to y-axis, right? And click continue and save residual, unstandardized residual. Click unstandardized residual. Click continue. Option, no problem at all. Style, okay, no problem. And click OK. All right. Can you see my output? Can you see?
Yes, sir. It's visible.
All right. Can you see?
Yes, sir. It is visible.
Oh, okay. Okay. Thank you. Thank you. So what we have to do it, we have to take a three more table from the output. One is a model summary. One is the model summary. From this model summary, this is the R value. This is the correlations value. The total correlations in the model. This is a 0.364. R squared value. This is the very important value we have to take. Right. R squared value is a 0.1333. So this means only the 13% has a power, impact power, right? It has a power to determine the dependent variable, right? How we can explain this? If it is a 13.3 of this variation of the 13.3 of the variation on MAPP, right, can be explained by strategy, technology, and commission. All right. So this R squared 13.3. This is a very less amount for this model. For a social science research, it must be at least 20 or 25 or 30 above. If the value is greater than 20 or 25 or 30%, it is good. All right. If it is a 50, 60, and 70, 80%, it's an excellent model. But in this situation, only 155 data we collected. Only 155 data. If that situation comes like that, what we have to do, we have to, that is what I told you, right? The sample size must be a larger sample, like a 400, 500, 600 samples comes. So the model fitness will be proved. And again, we have to move to this ANOVA table. You have to look into the ANOVA. See here, the significant values. The significant value is less than 0.05, which means that at least one of the three variables can be used to form a model. So that is what it's called. The model is a fit. The model is correct. There is no issue in the model. And the third table, this is the very, very important table in order to prove your hypothesis, right? someone might have written hypothesis there is a relationship between the technology and the study MAP, or between communication, or between communication in the MAP, and between the strategies and MAPs, like that. So what we have to do is we have to find the model, right? Firstly, we have to look at here the significant values. Under this significant values, only one variable is supported. This is the commonly supported. Because why? The significant values is here 0.00, which is less than 0.05. Other two values are here. Other two values, for example, technology and the strategies, are more than 0.05. So these two variable, technology and the strategy, are not supported. The technology and the strategies are not supported by the data. All right. So what is your model? Y equal a plus bx is your linear equations model. Am I right? Y equal a plus bx is your linear equations model. When you take that y as a dependent, a is a constant value. The constant value is here 5.874, right? A is equal to 5.874, and the bx, only the b is here the communication. The communications is 0.316 so that's a bx. So this is your y equal a plus bx model. And after that, what we have to do it, this mean what? This is the equation state that y is equal a plus bx. 1 unit increase in your for example communication, right? 1 unit increase in communication. The management accounting practice expected to be higher by 0.316. 1 unit increase in communication is expected to be higher by 0.316. Okay, this is the interpretation of this linear equations model. And next one we have to check multicollinearity. What is multicollinearity? As I already explained in the slides, there is a rule of thumbs. We have to check the multicollinearity issues from differently. Because why? The multicollinearity means we have taken the 3 independent variable and 1 dependent variable. We have to check, is there any similar variable among these 3 variables? If these 3 variables are different, the model is all right. If there is a multicollinearity problem is available in the model, that means there are similar variables available in your construct, model, right? So that what we have to do it, if there is any multicollinearity issue, then we have to remove a variable, right? Okay, we'll go with this rule of thumbs first, right? We have to look at the first VIF value. The VIF value is less than 5. So all the values are here. Communications is less than 5. Technology less than 5. Strategy less than 5. So there is no multicollinearity problem in the model. So one conclusion. Second, we have to test this tolerance. Tolerance value must be greater than 0.2. Tolerance value must be greater than 0.2. So all these 3 values of tolerance are above 0.2. Are you all agree? You understand?
Yes, sir.
Right. All these tolerance values are above 0.2. So there it says that there is no multicollinearity problem. And again, another two tests are there under the collinearity diagnostic table. One is eigenvalue, right? Eigenvalue must not value closer to 0. Eigenvalue, if the eigenvalue is closer to 0, there will be the multicollinearity problem. Is there any closer to 0, any values? These are the eigenvalue. There is no closer to 1, not 1, 0, not 0. All right. All four values are away from 0, right? Away from 0. And the fourth one, to prove the multicollinearity issues, condition index can be used. Condition index. This condition index is less than 15. We can conclude there is no multicollinearity problem. So by having this four different theories to prove the multicollinearity issues in the model, so we can conclude there is no multicollinearity issues in the model. All right. Okay.
Okay.
Right. Okay. So this is what we have to run this correlation and the regression analysis for any different kind of research. Okay. I'll take my slide here. Can you see my slide? Correlations between variables. This all everything we went through practically. We have seen all practically. This is the 3 less value must be 3 and above, and between 3 and 0.85. If there is any issues, any items found 0.85, there will be the multicollinearity issues, right? And R square, what is R square? We have seen. And so these are the criteria for a multicollinearity based on this VIF value, right? VIF value is less than 0, multicollinearity is not serious. If the VIF value is a little higher than 5, substantial multicollinearity problem is there. If the VIF value 10, multicollinearity is a serious problem. It is a serious problem, right? Okay. So that what we have to do we have to concern on the multicollinearity issues, right? So that is the example we have seen in our analysis. Again, I'm going to tell you what, for example, how to transform missing data. As I told you in the beginning, how to transform our missing values, isn't it? Here with, for example, where I touch you in the right here, how to transform, replacing missing values. Select the variable and click OK, right? If there is any missing value, automatically we can transform. For example, I'll show you. Okay, I'm going to share the data. Okay, and go to transform, click transform. For example, before that, the missing data must be available. So in our data, no missing data, but I'll make the missing data here. Okay, I'm going to remove this data. This says this shows what? There is a missing values in the data. Am I right? Understand?
Yes, understood.
Right. Okay. So what we have to do we have to click this transform and come down to bottom, replace missing value. Right. Here the new variable, we have to move this one, close new variable. Now it is going to form a new variable. All right. It's going to form a new variable and click OK. Right. Okay. Now it shows that the number of replace missing value 1. Okay. Go to data now. I'm going to share the data, show you the data. It's loading. Give me a few minutes. It's loading. I don't know why it's take times. All right. Can you see my screen? Can you see my screen?
Yes, sir, can see.
Right. Okay. So this is the str1-1, the missing variable form here. So on the top, we had a blank. You see here, it is a blank, you know, that is called missing value. All right. And after that, what we have run this here to form a missing value, replace a missing value. System automatically replace 4.2 based on the mean value. Based on the mean value. This is the new variable. So what we have to do it in order to analyze further, we have to take this strategy. This is the one item, and again we have to take other 3 items: strategy 2, strategy 3, strategy 4. Not to this one, because we have to exclude this item and replace this strategy 1. Okay. Again, one more important point I'm going to show you: how to find the outlier from the analysis. Find the outlier. Okay. Okay. If you find the outlier for any variable, right, any items, you have to go to click on graph, legacy dialog box, and come to here, box plot. Okay, and click on symbol. Click the summaries of a separate variable. Click this summaries of separate variable and click define. Okay, now what we have to do it, for example, I'm going to take the last or the second one, whatever, second or third. Okay, I'll take this ST2, 3, 4, right? All right. Even we can bring everything, it's no issue, right? Okay. So I have taken here only 3 items here. We can take all, no issue. Or even if you can run one by one, no issue. So we have brought here all this str2, 3, 4, and after that click OK. All right. So when you compare here, the str2, it is okay, good, and str4 also good, but there it is on the top, and but the 3 is having a problem. Outlier problem is there. You know, the item 22, item 6, not item, the row numbers 22, right? Row number 22, it is a problem. Row number 6, there's a problem. Row number 146. So this is the way that we can find the outlier. All right. Okay. So after this, I have other 3 very important area. One sample t-test, independent sample t-test, one-way ANOVA. These three are all very important to do your further analysis. For example, you wanted to make the different. You wanted to find the difference between male and female to your model. How the male influence is most preferred than the female. If you want to find that results also, so independent sample t-test can be used, because we are going to compare only two. If we are going to compare the more than two values, for example, based on the employee categories, managerial level, middle level manager, supervisor, for example, or bottom level, like that. For example, 3 level of employees are there in your organization. You wanted to measure the influence pattern on their motivations, or influence level on the motivations of employee satisfactions. If it is so, the option is one way and can be used, because that can be used for a 3 items. If there are 3, if there is only one values, it has the population's mean it has, and now you have to compare these any differences between the population's mean and the result value. So that situation is one sample t-test can be used. So these are the remaining 3 area. But as I told you in the beginning, right, in the beginning, the time is not enough to cover everything. I have covered all other sections, all other important sections, especially most of the students are facing how to run the correlation, how to run the regressions analysis, and how to run this descriptive analysis also. But in the meantime, the many students are facing what is EFA, what is CFA, EFA, exploratory factor analysis, and the confirmatory factor analysis, CFA. The most of the researchers are fail in order to identify what is EFA and the CFA. Right. Actually, when you run any theoretical model found, for example, service quality model is already tested model, or else IS success model, Dillon McLeod 1993 model, which was a tested model. So if you are going to test the model or apply the model to Sri Lankan context, so we don't want to run the EFA. We are not forming any variable. The already validated variable can be used for our study. But if there is a few studies or no study conducted by you, if you are doing the grounded theories and in-depth analysis, for example, firstly you are the only one, you are going to have developed measures and the variable. So that situation, so you have to run the EFA, exploratory factor analysis, and you have to find some measures for which you have to bring whether these measures are suitable or not. So that is the way that we apply the factor loading. All right. So we have to make sure whether these items are suitable to this variable or not. Then after we can name that. So these all we covered. Okay, this is what we have covered up to now for 12 o'clock, Mr. Riyadh. Anything to be discussed from the audience and the participant? Yeah, let me know.
Okay, sir. Thank you very much. So from the audience side, if we have any questions, we can ask a question here. Any questions, please?
Sir, suppose few variables are already identified, and then I want to find a new variable. So in that case, can I apply the exploratory factor analysis?
Yes, of course. You are putting the new variable, right? So that situation, the study is not validated for that the particular identified variable. The study not validated. Validated mean if the variable you found were taken by many researchers, and they have proved, they have concluded that this is the variable is suitable for this model like that. In such situation, no need. If not, we have to do.
Okay, sir. And then one more question, sir.
Yeah, sure.
Suppose just yours, this is just for your suggestion, as I am not the statistics. Suppose let's assume that my variable is dependent variable is customer satisfaction, and independent variable I have around 3 to for the relating to the quality of the service. So in
Okay.
that case, what kind of analysis tool you suggest, like factor analysis or multiple regression? Which one is most applicable?
That means you have a number of independent and number of dependent variable, isn't it?
Yeah.
So you have a new models, right? You have a number of models you can form, right? For example, if you have a 3 dependent variable, model 1 for one variable, model 2 for the second variable, and 3 variables, you can run and show the difference between the model 1, 2, 3 like that. And also you can use structural equation modeling. Structural equations modeling will support you to run together, right? Run together and find the solution.
Okay. What about this multiple regression? Those are not suitable.
Multiple regressions cover under the structural equations modeling. That is the advanced versions of the usual model running.
Okay, thank you, sir.
Yeah.
Sir,
Yes.
if we found a multi-collinearity in the model, it means
Okay.
the similarity in the independent variable. But we
Okay.
can do the drop out.
We have to remove the variable.
Sorry, sir.
You have to remove one variable.
Remove one variable.
Yeah.
And continuing analysis with the
Yes.
multi-collinearity, what will happen?
After removing, we have to run the analysis again.
No, sir. Continuing analytical studies without removing the multi-collinearity problem. What will happen?
If you wanted to do like that, you have to recollect more data again. You have to increase the sample size.
Sample size. The second option is increasing sample size.
Sample size.
Okay, thank you, sir.
Yeah.
Right, any questions? One more request. I have shared feedback link in the chat box. Please fill the form. So if anybody wish to get the certificate of participants, so I can distribute after the discussion with the head of the department and the dean of the faculty. Please fill that form, and your feedback will be very helpful us to improve our future webinars. Any other questions? Any other?
And can we get the recording and the this material?
Yes, I have record the session. I will upload the session
And,
recording in our official YouTube channel of our faculty. So today itself, today or tomorrow, I will upload it.
And those 3 areas were not covered. One sample teachers, independent sample teachers, one-way ANOVA. All the material I have developed, and I'll be able to forward to you all. Right? If you have any new sessions, no problem. I can explain those 3 also, and those material I can share with you.
Okay, doctor, I will share the materials, your material in our website. So the site is under construction. We'll publish all the data and the materials, the recording link in that website. Thank you very much, Dr. Halim.
And one more thing I want to share with the audience. Thank you for being with us for this seminar, and I hope I have delivered a good session for you all, and you will understand the way how you can do the statistical analysis using SPSS and how you can carry out your research in the future also. Mainly I have focused here most of the students and other researchers facing troubles in analyzing the data and with their model. And of course, my suggestions, the great suggestions I can give you, if you have a more number of sample, there will be no issues in your analysis, right? Anyhow, don't limit your sample below 100 or 150, 200. Anyhow, based on the population and based on the guideline to select the sample, increase the number of samples. For example, the sample, according to the sample formula and the sample criteria, it is said that it is a 384, it is a minimum sample. Okay, no problem. Don't limit to 384. You go with the 600 or 700. In such a situation, your real data will be useful for bring the result, and that results can be used for the final findings. So the findings will be valuable to the decision makers and the policy makers. So that is what I'm telling. Increase your number of sample size. Okay, thank you very much, all of you, right, being with us and having this opportunity for learning this SPSS applications in the analysis of data. Thank you very much for Riyadh, who has organized this session, and he already emphasized to me, because of all our final year students and other researchers, he said definitely will get the benefit from these sessions, like that he said, and I agreed to have this session. So with a short of information, he has organized the good programs to the researcher, and I hope this will direct you in a forwarding directions to in your future. Thank you all. Thank you very much, coordinator, for giving me the opportunities to being with this audience for 3 hours.
Thank you very much, sir. You're welcome. And you have done a great job. Many of us learn a lot from you today. And also we have polished our knowledge. And so I have requested you to do a session. So you have agreed. So thank you very much for that. You have spent your time and your effort. Thank you very much, sir. And also in future, we will invite you to do a continuous session. So I hope you will agree on that and to share your knowledge from us. Thank you very much, sir. And also thank you very much for our audience to participate and cooperate with us.
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you all. See you.
Yeah, thank you, sir.
Thank you, sir.